Okay, so the final section in chapter 1 is dedicated to solving problems, which is great because we're going to be doing problems right the rest of the semester. A large portion of what we're doing is going to be just solving problems, calculating things and figuring stuff out. So Tro wants to suggest a way to do this, and he dedicates the last section, section 1.8 of chapter 1, to it. So the first part of the chapter goes, of the section goes to converting from one unit to another, and he uses something called dimensional analysis and conversion factors. And then the second section is general problem solving strategies. And I want to emphasize here that he suggests something on page 27, a 4-point strategy, and it goes like this: sort, strategize, solve, and check. And I think it's a good way to do things. It may be the best way, but I find that students at this level, oftentimes, if they don't come into the class already knowing how to do this, Tro's way is generally not helpful. So what I'd like to do is suggest something that's like the Tro way, but it's something that I learned in my training as a Jedi Master, and it's called, well, the Jedi Way. So the Jedi Way is like the Tro way in some respects, but doesn't require as much foresight. So in the Jedi Way, what we're going to do is we're going to, first of all, identify the units of the answer. And then we're going to incorporate the units necessary, getting rid of the units that are not in the answer. This will make more sense as we're doing it. And then we're going to calculate ever so carefully. And then finally we're going to check and make sure that the answer makes sense. Okay, this is the Jedi Way, and it's something that that is the way I'm going to solve problems when I'm showing you. And if you feel a sense of disorientation, then I'm going to recommend that you get used to this. I should warn you at the outset that you're not necessarily going to like it right away. This is this is the kind of thing that you're going to have to get good at. It's sort of like driving a car, right, or riding a bike. When you first do it, you don't feel comfortable with it, but eventually you have to learn to do it right, and only then are you ever going to be really good at it. So, all right, so I'm going to suggest the Jedi Way, and I'm going to keep reminding you of these 4 steps: aim, close your eyes, squeeze, and then open your eyes and check your work. So let's do an example. First example I want to do is unit conversion. So if we're doing the Jedi Way, the question is identify the units of the answer. So if I'm going to identify the units of the answer, what are the units of the answer? Convert 1.76 yards to centimeters. The units of the answer are centimeters, right? Okay, so now what I've got to do, oops, you know what? I'm going to first of all incorporate a couple tables, right? Because we might need these for conversions, okay? So first thing I'm going to do, identify the units of the answer, centimeters. Then I'm going to come down here, and I'm going to find that in my solution somewhere I've got to incorporate centimeters, right? Because it's in the answer. Then I have to think, well, I'm coming from yards, right? And so I've got to get rid of yards somehow and incorporate centimeters. So let's go down here to lengths, because centimeters is a length, and I find, oh, centimeters can be converted to inches. So centimeters are like inches. Now in the Jedi Way, the second part, closing your eyes, we've got to getting rid of units that are not in the answer. There's no inches in the answer, so I've got to cross it off. And the way to cross it off is to put it up here, right? Well, I think you can already see where I'm going with this. Inches can be converted to yards, right? And yards cross off ultimately then too. So let's go down here, change the color. Black. So how many yards was I given in the question? 1.76. How many inches in a yard? 36 inches in 1 yard. How many centimeters in an inch? 2.54 in every one. Now to incorporate the sig figs. How many sig figs in this number? There's an infinite number because it's exact. This is an infinite number because it's exact. This is an infinite number because it's exact, right? By definition, there are 36 inches in a yard. Infinite, and there are 3 sig figs in this number. So my answer, there are going to be 3 sig figs. So what I'm going to do now is I'm going to go to my calculator. I'm going to type in 1.76 times 36 times 2.54. And I'm going to find that it gets me 160.9344 centimeters. Well, I need to report this to 3 sig figs. But I can't just say 160. Oh, I do round this up. Yeah, I round it up. It actually goes to 161. And that has 3 sig figs in it, and there's my answer. 161, okay? So I calculated. First thing I did was I aimed. I aimed by finding the units of the answer, and then I incorporated the units of the answer into my questions, into my solution, and got rid of all of the units, yards and yards, right? See, yards cross off, inches cross off, and centimeters cross off. Okay, that's step 2 of the Jedi Way. Step 3 is to calculate, so I did that very carefully, put that in my calculator, 1.76 times 36 times 2.54. And then the final thing I need to do is I need to open my eyes and say, does this make sense? I need to check it. So 1.76 is about 2. 2.54 is also about 2. Can you agree with me that 1.76 times 2.54 might be kind of like 2 times 2, which is 4, right? 4 times 36. 4 times 30 is 120. So 4 times 36 is like 150. And that's close to 150. So I would say, yeah, when we open our eyes, I think that number is good. I bet that it's correct. I'm not going to recalculate it in my calculator. If the stakes were high, if this were a quiz or exam, I would recalculate it. But we've opened our eyes, and I agree that that's a good number. Okay, let's go on to another one. Okay, so unit conversion. I'm going to do the same thing here. I'm going to say, you know what? Let's go back and look at our tables. These tables are always going to be available to you. They'll be on the front page of your quiz or exam. So the first thing we need to do in the Jedi Way is to aim. That is, we've got to think, what are the, you know what? Let me come here with a different color. Red. We've got to find the units of the answer. So what are the units of the answer? Cubic centimeters. Right? Okay. Then the second thing is to find some unit, some conversion that will give me cubic centimeters in my answer, right? So here's my work over here, and I've got to have cubic centimeters in it. Now, volume, it looks like 1,000 cubic centimeters is 1 liter. 1,000 cubic centimeters is 1 liter, right? So I can relate that to liters. But there's no liter in my answer, so I'm going to have to cross it off somewhere. So look, at liters are going to get crossed off. I'm going to quarts eventually. So sure enough, there's liters to quarts right there. Liters to quarts, quarts. So I can see all my answers my units are going to cross off, and I'll be left with the units of my answer, which is exactly what I wanted. Okay. Now let's put the numbers in. Color black. Let's put the numbers in. It looks like it was 1.8 quarts. Haha, 2 sig figs, right? How many liters in a quart? Looks like there's 1 liter in 1.057 quarts. Okay, how many sig figs in this number? That's exact. 1. There are 4 sig figs in this number. Centimeters, cubic centimeters to liters. There's 1,000 cubic centimeters in 1 liter. How many sig figs in that one? It's an exact number. How many sig figs in this? It's also an exact number. So the lowest number I've got in all of this is 2. My answer is going to have 2 sig figs. Okay, so the last thing I've got to, or the second to last thing, number 3, I've got to squeeze. I've got to calculate the numbers very carefully. So I'm going to go to my calculator and I'm going to say 2. No. 1.8 times 1,000 divided by 1.057 divided by 1. And so the answer comes out to be 1702.93 and so on, right? Well, I've got 2 sig figs in this, so I'm going to report this as 1700. Tro says in the sig figs chapter, if you want to be careful to make it really clear how many sig figs are there, you can write this in scientific notation, 1.7 times 10 to the 2 cubic centimeters. All right, now I want to think about this for a second. How many cc's? Well, you know what a cc is? A cubic centimeter is about, I don't know, maybe the end of my pinky, which you can't see. It's maybe the last knuckle past your pinky is about a milliliter. Could there be 1,000 or, oops, I got this wrong. I said 1,700. That's 3. There's 1,700. It was 170 as I wrote it a moment ago. Are there 1,000 of those possibly in a quart? Yeah, it's possible. Sure. Let's look at it a different way. What's 1.8? What's 1.8 divided by 1.057? Well, it's about 1.7, isn't it? Look at that. 1.8 divided by 1 is really close to 1.7 times 1,000, and there's my 1,000 right there. Right? There's 1,000, and there's 1.8 times 1.057. So yeah, this makes sense. All right, so the last step in the Jedi Way is to open your eyes or ask ourselves, does this question make sense? First thing, again, first step we're doing is to aim, and then we're incorporating units as necessary, which I did in red here. Then we're calculating, which I did in black, and then I did with my calculator. And then finally we're asking ourselves, does that make sense? Okay, so let's do another. Unit conversions involve units raised to a power. All right, so Tro's going to explain this pretty carefully. Well, he doesn't get into it very deeply, but he explains it on page 29. I'm going to explain it here in this slide. Calculate the displacement, the total volume. Do I have the... Yeah, there you go. Okay. Calculate the displacement, the total volume of the cylinders through which the pistons move, of a 5.7 liter automobile engine in cubic inches. This is a big engine, by the way. This is bigger than this is a big engine. Okay. Calculate the displacement. All right, so first thing we're going to do is come here. Let's go to red. Go back to red. Okay, first thing we do is aim the Jedi Way. Find the units of the answer. Calculate the displacement in inches, in cubic inches. Uh-oh. Okay, so it'd be nice to have cubic inches here somewhere, but I don't think I have cubic inches. I do have a conversion of inches to centimeters, though, right? Inches to centimeters. So I can do that, because I know that ultimately, I'm starting out with liters, right? Ultimately, I've got liters to cubic centimeters. There you go. That's going to do it. Right? Now I've got cubic centimeters here, which I've got to get crossed off, right? You see that? You see this is cubic centimeters because it's cubed? Okay. This is critical. Cubic centimeters to liters, that's just a 1,000 to 1. Okay, so now all these units are going to cross off nicely, but this is the key part, and this is the whole reason that Tro gives us this example right here. So here's the key part. Now I'm going to go back to a different color. Black. What are the conversions here? Okay, so it's 1 for 2.54 centimeters, and here's the critical part. This is cubed, and that's cubed, right? Because it was cubed on the outside. So it's really 2.54 cubed. The most common mistake for this problem, the one like it, is going to be here. Right there, that's it. Okay, how many cubic centimeters in a liter? There's 1,000 cubic centimeters in a liter. That's right here, right? And the liters is 5.70. Okay, so sig figs. There's 3 sig figs here. An infinite number here. An infinite number here. Because this is exact, right? Look at that. infinite number here, and so my answer is going to have 3 sig figs in it. Okay, so the last thing I do then, or the second to last thing, right? Still, I'm in the squeeze stage. Calculate ever so carefully. 5.70 times 1,000 divided by 2.54 raised to the third. And I get 347.83. Okay, well, I'm only allowed to use 3 sig figs, so this gets reported as 348 cubic inches. Okay, that is a big engine. I had a Mustang 20 or 30 years ago, 25 years ago, I guess, and I had a 5.0 liter engine in it. And Ford, we didn't talk about it in terms of liters at the time. It was 302 cubic inches, 302, which is, and it was fast. All right, it was a big motor. Okay, so the answer for this is 348 cubic inches. The final thing we're going to do is we're going to open our eyes and say, does this make sense? And I just did that, actually. Should have been calling attention to what I was doing. But I was saying, you know what? I know 5.7. Remember, I had a 5.0 liter Mustang 25 years ago. And I also know that it was a 302, right? So this is a 5.7 is bigger than 5. And 348 is bigger than 302. That's common knowledge. That's some knowledge I took in with me. So maybe that's not going to help you. Maybe you have to say to yourself, if I've got 5.7, that's 5,700 divided by 2.54 3 times. Is that going to give me that? Right? That's a good question. What is 2.54 squared? It's something like 16, I think. Okay, 2.54 maybe, I don't know what it is, 2.54. It's maybe something like 16. So this one's a little difficult to do in your head. But rounding is a good idea. Do you ask yourself, does it make sense? Sure it does. 5.7 liters cubic inches is a lot smaller than a liter, and so there must be more of them to make them equal. Okay, let's do more. The mass of fuel in a jet must be calculated. Do I have yeah. The mass of fuel in a jet must be calculated before each flight to ensure that the jet is not too heavy to fly. Okay, a 747 has this many liters of jet fuel. If the density of fuel is such and such, what is the mass of the fuel in kilograms? All right, so the question here is, if we're using, all right, let's do this. Let's pretend like we're still doing Jedi, right? Let's pretend we're still lost. First thing we're supposed to do is aim. And the first thing we do is aim and find the units of the answer. What are the units of the answer? Kilograms, right? And we know the first thing we've got to do is have some conversion factor that has kilograms in it. Okay? Now I can see up here I've got grams, cubic centimeters, and liters. All right, so the first thing I'm going to do is I'm going to go, well, I've got to get it to grams eventually. Kilograms, and that way I can bring that into it, okay? This is a conversion I have somewhere in my head or down here, okay? Now that I've got that, grams I got to get rid of because there's no grams on my answer, right? Ha! Grams are related here to cubic centimeters, and that's why this is called a conversion factor, okay? Because this is really just the density, but it's being used as a conversion factor. So grams and grams. Okay, cubic centimeters are going to have to get crossed off because it's not on my answer, right? And look at that. I'm going to have to go to liters. Well, I've done this a couple times now. The last couple problems I've had a grams per, or cubic centimeters per liter. And there's my liters. There's my measurement. Okay, can you see that the liters are going to cross off? Cubic centimeters are going to cross off. Grams are going to cross off. And I'll be left with kilograms like I wanted. Okay, that's the Jedi way. Let's go back to black. How many liters am I talking about here? 173, 231. cubic centimeters per liter. Grams per cubic centimeter, 0.768 per 1, right? And kilograms per gram, 1 for every 1,000 grams, right? So how many sig figs do I have here? This is just a conversion factor, and it's exact. It's a definition, okay? This is exact here, and this has 3 sig figs in it. It's not exact. This has, it's a definition, so it's exact. Okay? And this has 6 sig figs in it. 6. So how many sig figs are going to be my answer? 6, looks like the smallest one is 3. Okay? So let's calculate this out. 173.31 times 1,000 divided by 1,000 times, forgot the 0.768, 0.768. Okay. This looks like it's going to be 133-041.408. Okay. It's supposed to be 3 sig figs, so let's say it's 133,000 or 1.33 times 10 to the 1, 2, 3, 4, 5. Right? This is explicitly, this has 3 sig figs in it, but Tro says in the beginning, let's use this here. Kilograms. Okay? All right. So last thing we're going to do now is ask, does this make sense? 173, the thousands cross off. I should have just done that in the beginning. Okay? 173 times some number smaller than 1. So yeah, it's going to go to something smaller than 173. How much smaller? Well, I'm not sure, but that's about right. Okay, so I'm going to say, yeah, that number makes sense. Okay. All right, let's move on. Let's do problems with equations. All right, so find the radius in centimeters of a spherical water droplet. I don't think we have any, no, we don't have anything to go here, okay? The radius of a spherical water droplet, let's go back to red, with a volume V of such and such, okay? For a sphere, V is equal to 4/3 pi r cubed. Well, we're supposed to find the radius in centimeters, right? So before I do anything else, I'm going to say, we got to solve, we're looking for radius, okay? So let's multiply both sides by 3/4. Now let's divide both sides by pi. Okay, and finally, let's take the cube root of both sides. So r then is going to be cube root. Okay, so you know what? It looks like we don't even need the Jedi way here. We're going to solve this with a an equation. So this is going to be, I'll put all the numbers in here and then we'll solve it. The cube root of 3 over 4 pi times v. Right, and it was in cubic centimeters. So this is going to work. The cube root of cubic centimeters is going to be cubic centimeters. So I'm going to solve this with my calculator now very slowly and ask if it makes sense. 3 times 0.058 divided by 4 divided by pi raised to the 3rd cube root. Okay, and this comes out to be 0.24013 centimeters. I'll ask you in a second if it makes sense. Let's look at the sig figs here, okay? This is a definition, so This is a definition, so infinite number of sig figs here. Infinite number of sig figs here. There's not an infinite number of sig figs. Well, there is an infinite number of sig figs in pi, but I can't calculate with that many. But I use my calculator, which uses a bunch. So let's say we did, I'm just going to make something up here. We had 40 sig figs here, because your calculator uses just a ton, right? Because I just put that pi in automatically. I did not say 3.14, 15926, whatever. Okay, now this number though, aha, 0.058, that's got 2 sig figs in it, okay? So something with 40 times something with 2, yeah, this number's going to have 2 sig figs in the answer. So I'm going to report this as 0.24 centimeters. Now I'm going to ask myself, does that make sense? Does that make sense? Well, it's a little difficult to say because it's difficult to relate cubic centimeters to centimeters by eye. So I don't think we can do a whole lot here. It does make sense. It is the right answer, by the way. But I don't think there's a whole lot of gut check we can do here. Okay, let's move on to the last problem, and then we'll be done. Find the density in grams per cubic centimeter of a metal cylinder with a mass of blank. Uh-oh. All right, so got all kinds of trouble here. But in a radius of such and such. All right, this is difficult. All right, so what I'm going to do first of all is make a note here. Go back to red. Find the density. All right. Grams per cubic centimeter of a metal cylinder with a mass of that. Okay. Okay, this is where the Jedi Way really pays off. Because I'm looking for grams, right? Well, I don't have to relate it to anything because I have it just as a measurement here, right? So I can just relate it to 1. It's just introduced as a measurement. Okay? But now cubic centimeters now, that's going to be a bit of a challenge. So it looks like I've got centimeters here. And centimeters here. And it's going to be radius squared, so I don't have to... You know what? I've got volume here, and I know that density is equal to mass per volume, so I'm not going to do this. I'm going to go with density is equal to mass per volume instead. It's going to ultimately end up being the same thing, of course, but I want to keep this clean. Okay? So the mass, as I can see, is simply going to be there. But I got to find the volume, 1 over volume. Can you see this is equal to density is equal to mass per volume, where volume's in the bottom? Okay, so volume now, let's go over here and say volume is equal to pi r squared L, right? Pi r squared 0.55 squared, and L is 1.94, okay? This has got 2 sig figs in it. This has 3. Okay, so ultimately this one's going to be 2 sig figs. This has got 2 sig figs anyway. All right, so let's calculate this with our calculator very carefully. Pi times 0.55 squared times 1.94. Okay, this is going to come out to 1.8436, all right, and so on. So I'm going to take this and put it on the bottom, and the way that I'm going to do that is I'm going to say V raised to the negative 1 times m, which is the same thing I have here, is going to equal density, which is going to equal 1.8. This is still in my calculator now. That's why I don't want to re-enter it in my calculator, because it's chances for mistakes times 8.3. Writing a little fast, getting a little, see the end in sight. So, okay, raised to the minus 1 times 8.3, and that gives me 4.502. 4.502. Okay, and I'm supposed to give this, there's going to be 2 sig figs in my answer, and so this is going to be reported as 4.5 grams per cubic centimeters, because this was in cubic centimeters, right? All right, 4.5 grams per cubic centimeter, and that is my answer.